So let us see, according to this theorem, volume integral of a divergence of vector A is same as closed surface integral of that vector where surface S surrounds volume V. So this is the divergence theorem. So you can write volume integral of a divergence of some vector A is same as closed surface integral of that vector which surrounds volume V. So that is the statement of divergence theorem. Now we will take different examples and then we have to verify this theorem. So let us take this vector A is given as twice x z x cap plus x plus 2 y cap plus y z square minus 3 z cap. So this vector is given and a particular volume is also specified. So this is x cap, this is y cap, and this is z cap. This is the origin and its sides are 2. These sides are 2. Now you have to verify divergence theorem. So this volume is given and a vector function is given. So you have to verify left hand side and right hand side. So in left hand side you have to calculate volume integral. In right hand side you have to calculate closed surface integral, and both will give you same result. So let us verify it. So first calculate volume integral of a divergence. So you have to find divergence of A. And what will be divergence of A? This will be twice Z. This will be 0. And this will be 2yz. So, or you can say this divergence of A is twice Z 1 plus y. This is divergence of A. So in volume integral, you have to find volume integral divergence of A d tau. So this will be triple integral. This is twice Z 1 plus y. And what is d tau? Dx, dy, dz. This is the origin. So x, y, z varies from 0 to 2, y also 0 to 2, and z 0 to 2. So this will give you, if you differentiate with, yes,
will be given in the question itself, sir. Actually,
this volume is given, this vector is given, and this volume is given. That sides are 2. These are the known parameters. So if you differentiate with respect to x, first term will give you x, limit will be 0 to 2. With respect to y, so let us first calculate with respect to y and then with respect to z. So y will give you y plus y square by 2, y 0 to 2, and this z will give you z square, 2 will cancel out, z 0 to 2. So this value will be, this is 4, then this will be 2 plus 4 by 2, and then you have 4. So what will be this value?
12.
This is,
60.
this value will be 2. I think this is 2. So
32.
32. So left hand side is volume integral of a divergence of A will give you 32. Now you know that this volume is surrounded by closed surface. Any volume is surrounded by closed surface. So this volume is surrounded by how many surface? 6 surface.
6 surface.
So on each surface, now you have to find surface integral. So we will see how to calculate surface integral in Cartesian coordinate. So let us see surface 1. And direction will be area element on the surface 1 perpendicular to the surface pointing outward. So direction will be x cap. So surface 1 is x is equal to 2 plane. And what will be dA over this surface? dy dz x cap. This is dA over surface 1. And then find A dot dA. What will be A dot dA? If you take dot product with x cap, you will get this term. That is twice xz dy dz. And x is 2 here. So you have to put x is equal to 2. So then surface integral A dot dA is given by, this is double integral. X is 2. So you will get 4 z dy dz. Where y 0 to 2 and z 0 to 2. Integrate this. You will get 4. Y will give you 2. And z will give you, z square by 2 is 4 by 2. 2 will cancel out. This is 16. So on surface 1, surface integral will be 16. You can easily integrate. With respect to y, you will get 2. And with respect to z, z square by 2. So 4 by 2, that is 16. Similarly, surface 2. So opposite to this, you have surface 2. And since this is the origin, so opposite plane is x is equal to 0 plane. And what will be direction? Minus x cap. So surface 2 is x is equal to 0 plane. And dA will be minus dy dz x cap. And what will be A dot dA? So minus 2x z dy dz. And you know that x is equal to 0. So if you put x is equal to 0, A dot dA will be 0. So on surface 2, A dot dA will be 0. Similarly, we have to find on surface 3, 4, 5 and 6. So let us see on different surface. So just show the direction of area element. Surface 3, y cap. Surface 4, away from the surface, minus y cap. Surface 5, z cap. And surface 6, is minus z cap. So you can easily write on different surface. So surface 3, y is equal to 2 plane. And what will be dA? dA will be dx dz y cap. And then what will be A dot dA? X plus 2 dx dz. So then integral will give you, this integral value will be x plus 2 dx dz. So x will be 0 to 2 and z will be 0 to 2. So this will give you 4 by 2 plus 2 into 2 into 2. So what will be this value? This is 12. So this value will be 12. So on surface 3, surface integral will be 12. Then surface 4. 4 is y is equal to 0 and dA will be minus dx dz y cap. So A dot dA will give you minus x plus 2 dx dz. You have only minus sign, same limit. So this is minus of x plus 2 dx dz.
Excuse me, sir.
Yes.
Sir, in third, the integration value is not right, I think.
This will be 2, 6 into 2 is 12. Where is the problem? X square by 2 and this is 2x.
Yes, sir. Yes,
So
sir.
4 by 2 plus 2 into 2 and then with respect to z into 2. So this will be 6 into 2 is 12.
Okay,
Where is
sir.
the problem? So similarly, same integral with minus sign. So you will get minus 12 here. Now surface 5. Z is equal to 2 plane. So what will be dA? dA over this surface will be dx dy z cap. So what will be A dot dA? This is y z square minus 3 dx dy. Put z is equal to 2 here. So if you put z is equal to 2, this will be y 4 minus 3 dx dy. So finally integral will be, this integral will be y dx dy. And y will be 0 to 2, x will be 0 to 2, and y also will be 0 to 2. So this integral is y square by x will give you 2, y square will give you 4 by 2. So that is 4. And similarly, on surface 6 is z is equal to 0. So VA will be minus dx dy z cap. So A dot dA will be minus y z square minus 3 dx dy. Now put z is equal to 0 here. So if you put z 0 here, this will be 3y dx dy. 3y dx dy. So integral value will be 3y dx dy. Y is 0 to 2, x is 0 to 2, and y is also 0 to 2. So what will be this value? 3 into 4 by 2 into 2. So that is again 12. So you can see how to find surface integral on each surface. And then you have to find closed A dot dA. So you have to add up. That will give you closed A dot dA. So closed A dot dA will be given by add for each surface. So surface 1 is 16. Surface 2 is 0. Surface 3 is 12. Surface 4 is minus of 12. Surface 5 is 4 and surface 6 is again 12. This will cancel out 20. This is 32. So you can see divergence A d tau, that is 32, and closed A dot dA is also 32. So that verifies the divergence theorem in Cartesian coordinate system. Is it clear?
Yes, sir. Yes, sir.
So you know how to calculate volume integral as well as surface integral in Cartesian coordinate system. Now we will see example in spherical polar coordinate. So let us see next example. Now vector A is r square r cap. So let us see that is given in spherical polar coordinate. And volume is its volume is a sphere of radius r. You have to again verify divergence theorem. It's a volume. So you have to verify divergence theorem. So left hand side is divergence A d tau. So what will be divergence of A for this vector? In a spherical symmetry, you have this term 1 by r square del r square into AR. So that is 1 by r square into 4r cube. So this is 4r. Only AR term, A theta and A phi is 0. So you need only first term. So what will be divergence of A d tau? Now you have to see in spherical polar coordinate how to find volume integral. So this is 4r, and what is d tau? R square sine theta dr d theta d phi. What will be limit of r? 0 to capital R, theta 0 to pi, phi 0 to 2 pi. So calculate this integral. First term will give you 4 r power 4 by 4. Sin theta d theta 0 to pi is 2, and d phi will give you 2 pi. Sin theta is minus cos theta, and 0 to pi will give you 2. 4 will cancel out. So this value is 4 pi r power 4. This is the volume integral. Is it clear?
Yes, sir.
Now we have to see surface integral. So you have to write this volume is surrounded by how many surface?
One surface.
One surface. That surface is r is equal to capital R surface. This direction will be r cap. This is r is equal to capital R. So what will be dA over this surface? dA is, you know, that is capital R square sine theta d phi r cap. So what will be surface integral A dot dA? Closed surface integral, because this volume is surrounded by closed surface. So that will give you closed A dot dA. So this is, you will get, if you take dot product, and this small r is capital R, because you have to find at r is equal to capital R. So if you take dot product, you will get r power 4 sine theta d theta d phi. Limit of theta is 0 to pi and phi will be 0 to 2 pi. So again this integral will be r power 4 into 2 into 2 pi. So what will be this value? 4 pi r power 4. So you can easily verify divergence theorem in spherical polar coordinates also.
Sir, 1 minute, sir.
Yes.
Sir, in this the volume integral,
Yes.
4r r squared sin theta. The how the r squared sin theta.
In volume integral. So
Yes, yes, this one. Yes.
yes.
Downs, sir, downs. 4r into r squared sin theta.
This
dr
is
d theta.
4r in this is the volume integral. What is volume integral in spherical polar coordinate? I have written d tau. You can see r square sin theta dr d theta d phi. That I have already discussed.
Yes.
This is d tau in spherical polar coordinate. And then you know in
Okay.
spherical symmetry limit of r theta phi. So just integrate it. Is it clear or not?
Yes, sir.
So that is the first case. Let us see another example. Again in spherical polar coordinate. So in this case, vector A is given as this is r cos theta r cap plus r sin theta theta cap plus r sin theta cos phi phi cap. This is cos phi phi cap. Vector A is given in spherical polar coordinate and volume is a hemisphere. Let us consider this volume. You have a hemispherical volume. So this is x, this is y, and this direction is z, and its radius is r. So again you have to verify divergence theorem. So you have to first find divergence of A. So let us first calculate divergence of A. I have already calculated divergence of A for same vector. So just verify it. Let us verify divergence of A. Please calculate divergence of A. I have already calculated divergence of A. So you know AR, A theta and A phi, just substitute, you will get divergence of A. You know how to calculate it. So what will be divergence of A? Just calculate divergence of A. I have already calculated, you have to verify it. So this divergence of A will be 5 cos theta minus sin phi. Is it clear? When I have discussed divergence, I have calculated divergence of A for same vector. So you can easily verify this. ठीक है? Yes or no?
Yes, sir.
So now we
Yes,
have to
sir.
find volume integral. Divergence of A d tau. So this will be 5 cos theta minus sin phi. And what is d tau here again? R square sin theta dr d theta d phi. And what will be limits of r theta phi? Yes, r0 to r. What will be limit of theta?
0 to pi by 2.
0 to pi by 2. And what will be limit of phi?
2 pi.
0 to 2 pi.
Sir.
So it's a part of a sphere. you know, theta varies from 0 to pi by 2. So just integrate this. You will get the volume integral. So if you integrate with respect to r, this integral will give you r cube by 3. And then integrate with respect to theta. And finally, we will calculate with respect to phi. So you can see this is 5 by 2, 5 cos theta sin theta. So take it as 5 by 2, you will get sin 2 theta. So what will be integral of sin 2 theta? Minus cos 2 theta. And second integral will give you cos theta sin phi. And with respect to theta, this is 0 to pi by 2. And then you have to integrate with respect to phi. So I have integrated with respect to r, with respect to theta, and then finally we will integrate with respect to phi. So this integral will be r cube by 3 phi 0 to 2 pi. Now put, what will be this value? This value is cos pi is minus 1. So you will get plus 1 and then plus 0. So 2 will cancel out. So this will give you 5 by 2. 5. This will give you 5. Because cos pi is minus 1. So 1 plus 1 will give you 2. 2 will cancel out. And if you put cos pi by 2, this is 0. And then this is minus sin phi. And if you integrate with respect to phi, this will be 0. Sin phi 0 to 2 pi will be 0. So this integral is simply 5 by 3, 5 pi, 5 into. So what will be this integral? Please integrate it. What will be this integral? So this is r cube by 3. And if you take 5 by 2, so sin 2 theta will give you minus cos 2 theta by 2 also. I think here you have minus cos 2 theta by 2. So this will be 5 by 2. So if you put phi, so you will get r cube by 3 into 5 by 2 into 2 pi. So 2 will cancel out. You will get 5 by 3 pi r cube. So this is the volume integral. Now we have to see surface integral. So this volume is surrounded by how many surface?
Sir,
2.
sir,
Yes.
excuse me, sir.
Yes, yes.
So can't integrate sin phi?
Sin phi will be 0. I have integrated it because sin phi 0 to 2 pi will be 0. So I have taken integral. Let's take integral 0 to 2 pi sin phi d phi is 0. This is 0. That's why I have written this value. That is simple integral. Sin phi d phi 0 to 2 pi is 0. Yes or no?
Yes, sir. That is
Yes, sir.
even.
That you know, you can easily calculate this. Now this volume is surrounded by two surfaces, spherical part and lower circular part. So surface 1 is r is equal to r surface. So what will be dA on this surface? This is r cap. And what is surface 2? Theta pi by 2 plane. We have discussed dA on these two surfaces. So this direction will be theta cap. So you know dA on each surface. So let us first calculate on surface 1. So surface 1 is r is equal to capital R, and you know dA on this surface, r square sine theta d theta d phi r cap. So what will be A dot dA? So A dot dA will be r cube sine theta cos theta d theta d phi. If you take dot product, you will get only this term because r dot r is 1, theta dot r0, phi dot r0, and r is equal to capital R. So this will give you r cube sin theta cos theta d theta d phi. So what will be this integral? Take it as r cube by 2. So you will get sin 2 theta d theta d phi. Again theta 0 to pi by 2 and phi 0 to 2 pi. So this integral will be r cube by 2. Sin 2 theta is minus cos 2 theta by 2, 0 to pi by 2, and then that is 2 pi. So this value is 1. 2 will cancel out. So this is simply pi r cube. So this integral is pi r cube. Is it clear? This integral, this value will be 1. You can easily calculate. 2 will cancel out. So this is pi r cube. Now surface 2. Theta pi by 2 plane. So what is dA on this surface? That is, when theta is fixed, you have variable is r and phi. So that is dr into r sine pi by 2, because theta is pi by 2, d phi, direction is theta cap. So I have, that is r dr d phi theta cap. This is dA on theta pi by 2 plane. So take dot product a dot dA. Yes,
हेलो सर
yes.
सर फर्स्ट स्टेप में ये आपने पाई आगे क्यों लिखा है यहाँ पे इसलिए माइनस के प्लस को आएगा 1/2
बोलो क्या कह रहे हो?
2 से 2 कैंसिल हो जाएगा सर 1/2 आएगा ना यहाँ पे पाई अपॉन 2 आगे की
इन दिस केस
यस सर
नहीं, d phi is 2 pi, this integral is 1, so 2 will cancel out. प्रॉब्लम कहाँ है?
सर ये माइनस के cos 2 थीटा है ना, तो यहाँ पे पाई
भाई दिस इज माइनस cos 2 थीटा बाई 2, 0 टू पाई बाई 2. अब ये वैल्यू मुझे बतानी पड़ेगी. 1/2 कॉमन ले लो और इसको माइनस cos 2 थीटा. आई थिंक यू शुड रिवाइज दीज थिंग्स. सो 1/2, this is minus cos pi plus cos 0. Minus cos pi is minus 1. So 1 plus 1. This will cancel out, so you will get 1.
Okay.
Please revise your basics. So in this case, A dot dA, you have to take dot product with theta cap. So this will be r square sine theta. Again theta is pi by 2. So put pi by 2, because wherever you have theta, you have to put pi by 2. So sine pi by 2, r square sine pi by 2, dr d theta, d phi theta cap. So r square dr d phi theta cap. Now this integral will give you r square dr. This is not theta cap. If you take dot product, theta dot theta is 1. So r square dr d phi. So r is 0 to capital R and phi is 0 to 2 pi. So this will give you r cube by 3 into
2 pi.
So just add these two. So what will be closed A dot dA? This will be pi r cube plus 2 pi by 3 r cube, and that will give you 5 by 3 pi r cube. Same value. So divergence of A d tau is same as closed A dot dA. So that verifies the divergence theorem in spherical polar coordinate. Is it clear? So let us see next example. So next example is in cylindrical coordinate system. So next example, now vector A is given in cylindrical coordinate. So vector A is R 2 plus sine square phi R cap plus R sine phi cos phi phi cap plus 3z z cap. And volume is a quarter cylinder. Volume is a quarter cylinder. So let us draw this quarter cylinder. X, Y, and Z. So this radius is 2 and its length is 5. So over this volume, you have to verify the divergence theorem. So first you have to find volume integral in cylindrical coordinate system. Let us find volume for vector A in cylindrical coordinate. Again, we have discussed divergence of same vector A when we have calculated the divergence. So let us recheck it. What will be divergence of same vector? So let us calculate the divergence of same vector. Divergence in cylindrical coordinate. We have already calculated. You have to verify it. Just see in your note. Divergence of A is 8 for this vector function. Yes or no?
Yes.
I have already calculated. So you can recheck it. Divergence of A is 8.
Yes, sir.
So what will be volume integral? So volume integral of divergence of A d tau. So this will give you, now you have a triple integral R. And what is d tau in cylindrical coordinate? Yes, R, dr, d phi, dz. And what will be limit in this case? R varies from 0 to 2. And what will be phi? This xz plane is phi is equal to 0 plane and yz plane is phi pi by 2 plane. And this lower plane is z is equal to 0 plane and this plane is z is equal to 5 plane. So phi varies from 0 to pi by 2 and z varies from 0 to 5. So you can easily calculate divergence of A d tau. So this will give you 8, r square by 2 will give you 4 by 2, d phi will give you pi by 2 and z will give you 5. So this 4 will cancel out. This will be 40 pi. So volume integral of divergence A d tau is 40 pi. This is 40 pi. So that is the volume integral, left hand side of the theorem. Now right hand side, this volume is surrounded by how many surface? Yes,
Five surface.
five surface.
Five, sir.
Surface 1, r is equal to 2 surface. And what will be direction? R cap. Surface 2, z is equal to 5. Direction is z cap. Surface 3, z is equal to 0. Direction is minus z cap. Surface 4, 5 pi by 2. So this direction
Phi
is
cap.
plus 5
Phi
cap.
cap.
And surface 5, phi is
Minus
equal to
5
0.
cap.
This direction is minus 5 cap. So now find out surface integral on each surface. You have to write dA vector, take A dot dA and then integrate. Please try. So surface 1. Surface 1 is R is equal to 2. So what will be dA when R is fixed in cylindrical coordinate? Variable is phi and z. So you will get R d phi dz r cap. And then find A dot dA. So A dot dA will give you R square 2 plus sine square phi d phi dz. Now R is equal to 2. So if you put 2, you will get 4 2 plus sine square phi d phi dz. So this is A dot dA. So now we have to integrate it. And what will be sine square phi? How you can write sine square phi in terms of cos 2 phi? 1 minus cos 2 phi by 2. So then this integral will give you surface integral A dot dA will give you 4 common. This is double integral. Now you have 2 plus 1 minus cos 2 phi by 2 into d phi dz. Limit of phi will be 0 to pi by 2 and z will be 0 to 5. So what will be this value? 4, z will give you 5, and then this integral will be, this is 2 phi plus 1 by 2 phi, and what will be minus cos 2 phi? That is minus sine 2 phi by 4, and limit is 0 to pi by 2. Calculate this value. So sine pi will be 0, sine this last term will be 0. So this will be 20 into, this will give you pi plus pi by 4. So pi plus pi by 4, this will give you 5 pi by 4. So 25 pi. This is 25 pi.
Yes, sir.
So on surface 1, you will get 25 pi. Now find on surface 2. Let us calculate on surface 2.
Sir, how is it 25 pi by 4?
This is 25 pi. This 2 phi, if you put limit pi by 2, this will give you pi. And if you put pi by 2, you will get pi by 4. So that is 5 pi by 4. So this will give you 20 by 4 is 5, and 5 into 5 is 25. Just calculate it. Just calculate this in value. You will get 25 pi. Is it clear or not?
Yes, sir, yes.
Sir, there is a doubt.
Yes.
Sir,
Yes,
sir,
yes.
in integral 2 plus 1 minus cos 2 pi over 2 d phi dz.
Yes. So dz
Why
will give
we
you
have
5, and I have
Sir,
integrated whole term.
सर एक डाउट है, ये जो 2 है,
हाँ.
इस 2 को मैं z के साथ क्यों नहीं कंसीडर कर रहा हूँ? अगर मैं इसको z के साथ कंसीडर करूं
No,
तो
in this integral, when you have to integrate with respect to r, you have to take phi and z constant. When you have to integrate with respect to phi, you have to take other two constant, and then with respect to z, others are constant. That is how you have to integrate it.
सर यहाँ पे 2 तो कांस्टेंट है ना ये वाला.
So 2
ये
is
वाला 2 तो
constant. So I am integrating with respect to phi. This whole term is integrated with respect to phi. So constant, that will give you 2 phi. And z I have already integrated. That is z 0 to 5 is 5. This whole term is integrated with respect to phi. ठीक है? So now z is equal to 5 plane. So what will be dA over this surface? R dr d phi z cap. So what will be A dot dA? Last term 3r z dr d phi. Now z is 5. So this integral value will give you, this is, if you put z is equal to 5, so this is 15r dr d phi. So r is 0 to 2 and phi is 0 to pi by 2. So this is 15 4 by 2 into pi by, so that is 15 pi. Is it clear? This will be 15 pi. Now surface 3. Surface 3 is z is equal to 0. So calculate on this surface. Z is equal to 0. Again dA will be
minus 15.
minus r dr d phi z cap. So what will be A dot dA? Minus 3r z dr d phi. But now z is 0 here. This z is 0. So this value will be 0. This is z is equal to 0 plane. So A dot dA will be 0. Now surface 4. Phi pi by 2 plane. So what will be dA over this surface? When phi is fixed, variable is r and z. So you will get dr dz phi cap. So what will be A dot dA? You will get r sine phi cos phi dr dz. Now phi is pi by 2. Phi is pi by 2. So cos 90 will be 0. You can see phi is pi by 2. So this value will be 0 because cos 90 will be 0. And then on surface 5, phi is equal to 0 plane. So dA will be minus dr dz phi cap. So A dot dA is minus r sine phi cos phi dr dz. So in this case, phi is 0. So sine 0 will give you 0. So this is also 0. So finally you can write closed A dot dA. So surface 1, 25 pi. Surface 2, 15 pi. Surface 3, 0. Surface 4, 0. Surface 5, 0. So this value is again 40 pi. So you can see divergence A d tau is 40 pi and closed A dot dA is also 40 pi. So that verifies the divergence theorem in cylindrical coordinates. So we have verified divergence theorem in Cartesian coordinate system, in a spherical polar coordinate system, and in cylindrical coordinate system. And in each system, you know how to calculate volume integral as well as surface integral.